In this video, we're going to think carefully about one idea, the cross product. By the end, I hope this idea feels simpler and more connected. So, what is the cross product? By the definition, given two vectors u and v, the definition, given two vectors u and v, the cross product of u and v is the unique vector such that u cross v and the magnitude of it is equal to the magnitude of u times the magnitude of v times sine theta. And u cross v is an orthogonal vector to u and v. It's an orthogonal. You can think of it as a perpendicular to u and v. And the direction of the cross product, the output vector, can be determined by using the method called right-hand rule. Let me show you. For example, there's a vector u and v. Let's say there's a vector u points toward the right side from my perspective. So the vector u points here, that direction. And my pointer finger goes with the same direction as the vector u. And my middle finger, let's say there's a vector v points toward u, the camera, the screen. So then my middle finger points in the same direction as the vector v. So I'm not sure if you can see my fingers like visually good, but my pointer fingers goes here and my middle fingers points toward the screen. Then the output vector, the cross product, is my thumb. The direction of my thumb is the direction of the cross product. So as you can see, my thumb points toward the upward, the ceiling. That means the cross product of u and v, the direction is the upward. One thing you really need to keep in mind is that the order does matter. If we switch the order of the cross product, let's say v cross u, not u cross v, then we can also find the direction of the cross product using the right-hand rule. So since my pointer fingers was the vector u and my middle finger is the vector v, now we switch the order. Now the pointer finger goes towards u because it's the vector v, and my middle finger now points toward the vector u, so like this. Then, as you can see, my thumb points towards the downward, towards the ground. That's the direction of the new cross product vector, v cross u. So if you switch the order of the cross product, it gives the same magnitude of the new vector, but opposite direction. You need to keep that in mind. All right, we just talked about the definition of the cross product. However, what does actually mean? I know we know the formula of the cross product and like the right-hand rule, but what does it actually tell us? The cross product actually tells us how much two vectors point in the different direction in 3 dimensions. And also it produces a entirely new orthogonal vectors that encodes the area information. In other words, the standard cross product only makes sense in 3 dimensions. It doesn't make sense at all in any other dimensions, like 2 dimensions or any other dimensions other than 3 dimensions. Now, we not only know about the definition of the cross product and like the formula of it, but we also know about what it actually means. Now, I really want to talk about how we can find the cross product mathematically. Before do that, we have to learn about what it's called basis vectors in 3 dimensions. We're going to talk about it really briefly, but let me draw XYZ plane on the screen. So let's say X axis, Z axis, and Y axis here. All right, this is R3 plane. And the basis vector is, there are I hat, j hat, and k hat. I hat is a vector 1, 0, 0. J hat is 0, 1, 0. And k hat is just 0, 0, 1. These are basis vectors in R3. So they just tell us about the direction of those vectors in 3 dimensions. Their magnitude, each of their magnitude is always 1, so it doesn't tell us about the length of it, but it tells us about the direction information. Now, using this, we can find the cross product mathematically. One more thing we have to also know is that determinant. You need to note that determinant, we often note it as DET. Determinant of, let's say, a 2 by 2 matrix, A, B, C, D, is equal to, you can find the determinant of 2 by 2 matrix by multiply A times D minus B times C. This is kind of important to remember because we are going to find the cross product using the concept of determinant and basis vectors. One thing I forgot to mention is that each basis vectors, let's say I hat, goes only in the x direction, and the magnitude is always 1. And j hat goes in the y direction, only in the y direction, also the magnitude of 1. And lastly, the k hat vector goes only, oops, it's kind of thick, but only in the z direction with the magnitude of 1. So these three are 3 lines, 3 arrows are the basis vectors in 3 dimensions. Let's say there's a vector u equals u1, u2, and u3, and there's a vector v equals v1, v2, and v3. How can we find the cross product of u and v? We can find it using the determinant concept and the basis vectors. Let me show you the trick to find u cross v. The trick is, first write a 3 by 3 matrix determinant. Let's say I hat, j hat, k hat, and the second row goes with the u vector, vector u, u1, u2, u3. And the third row is vector v, v1, v2, v3, and determinant. This is equal to, first term is I hat times determinant of u2, u3, v2, v3, and minus j hat times the determinant of u1, u3, v1, v3, plus the last term is obviously k hat times the determinant of u1, u2, and v1, v2. That's it. This is how we can find the new vector cross product using determinant. Let me show you an example. Let's say a vector v. Let me show you with a pink colored pen. Let's say a vector u is 3, 1, minus 4. I don't know, just a random number. And vector v is equal to 2, 1, 0. Then the cross product we can find using the same method. So first, draw a determinant. I hat, j hat, k hat. 3, 1, minus 4. 2, 1, 0. This is equal to I hat times the determinant of 1 minus 4, 1, 0, minus j hat times the determinant of 3 minus 4, 2, 0. Lastly, plus k hat times the determinant of 3, 1, 2, 1. Now we just, the only thing we need to do is calculating the determinant. First term is I hat times 0 minus minus 4 is plus 4 minus j hat times plus 8 plus k hat times 3 minus 2 is 1. We can rewrite it as 4 I hat minus a j hat plus k hat. Now we can rewrite it as a vector form. So this is equal to 4 minus 8 and 1. This is the result. This is the cross product of u and v. The vector 4 minus 8 and 1. Alright, so we have learned the definition of the cross product, formula, and what it actually means and how to find it using mathematical skills. Now we are almost done. Lastly, I really want to talk about one really interesting property when it comes to the cross product. When you find the magnitude of u cross v, let's say when you find the magnitude of cross product, this gives you the area of the parallelogram determined by two vectors u and v. The area of the magnitude of this is actually the area of the parallelogram determined by these two vectors. Let me show you this property geometrically. Let's say there's a vector v, goes like this, and there's a vector v, goes like this. This is v and this is u. And you can see kind of the parallelogram when we draw two more vectors. Should be parallel. Like this. And there's an angle between those two vectors. And there's a height. And this height can be determined by multiplying magnitude of vector u times sine theta. Alright, so what I'm saying is that you can get the area of this parallelogram when you calculate the magnitude of the cross product. Pretty interesting, right? So today we have explored about the cross product. The main idea of the cross product is not just, it doesn't just give us a new vector. It gives us a geometric way to measure orientation and area. It's super useful concept when you're working in physics engineering, like calculating torque. If that connection feels clear now, this video did its job. Next time, we'll take these ideas to explore about lines and planes. Until then, let's keep things simply connected. Thank you.